Okay, we have started. So we'll go through simple ways on how we can have the knowledge about empirical formula and the molecular formula. They are just actually related to each other, but we'll see how they are related to each other.
Okay.
Sure. Alright. So before that, let me walk through with you what we call the periodic table. So this periodic table, it will have something that we call a nuclide. So a nuclide, I think I talked about in one of the lecture notes you sent me. So a nuclide, I mean your nucleoid. So this is just a symbol representing, let's say X is the nucleus of an element. Here on top it will represent the mass number, okay? Then here down it will present the atomic number, which is Z sometimes. By the way, let me use. Okay. So this mass number is represented by A. Sometimes this proton number is represented by Z. Is that okay? Hello?
Okay. I think the what is which color you're using? Which green? Which green?
Okay, I'll
On the
lab
other
it.
side, okay?
I'll lab it.
Oh,
I can't have black, but I'll have black later.
okay, okay, okay. Oh, yes, go ahead.
Alright. So, yes. So, what we need to understand is that there is what we call a nuclide. So a nuclide is a symbol of an element representing the mass number and the proton number. The mass number will be gotten on top, the proton number will be down. This is the periodic table for secondaries. Now that you are at the university, this will change. The nuclide of an element will be represented by, on top there will be finding numbers in decimal point, stuff like that. Let's say 9 point something. Those numbers are now the mass numbers. Is that okay?
Yes.
They are what you call mass numbers, but in this case, this periodic table, modern periodic table we are using now, they will be putting those numbers down here, and that's what we call for a mass number. Like for beryllium here down there, it is 9.01, so put 9.01. These numbers you find in points, they are what we call mass numbers of that element, or it's a molar mass of that element in short. Then the proton number in this case for these periodic
Okay.
tables, the proton numbers, they are these ones now on top there. Like 4 for this element barium.
Okay.
Yes, so those numbers, whole numbers without a point, they are what you call proton numbers. They are there to tell you the atomic
Okay.
mass of an element. We will not be using it under this stud, but we'll be using it, let's say under covalent, drawing the Lewis structure. We'll be using it because these are the number of electrons. These whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? These are electron numbers.
Okay.
Yes.
Mm-hmm.
Okay. So that is it about the periodic table. Then the other thing that we need to understand under the periodic table is the group of element, of which sometimes it's not that important, but we just have to understand. So,
Okay.
like these, they are what we call columns and rows on this periodic table. So the columns are the one that goes like this, right?
Mm.
So these columns are what you call groups. So the periodic table is divided into groups. So the first group is the group that you are able to see there, group 1. So the second group, which is the second column, is group 2. So the third group, we start from here, group 3. Then the four, these ones,
Where?
I'm on these columns.
Oh, okay, okay. I've seen.
The first column is what you call group 1. The second column is what we call group 2. The third column, you look at just at the column, don't matter the way I'm writing these numbers. Just look at the columns. The columns, the line that goes down there. They're what we call columns.
Okay.
So the third column is here where there is boron. The fourth column is where there is carbon. The fifth column is where there is nitrogen. So the sixth column is where there is oxygen. The seventh column is where there is chlorine. That's why chlorine they are from group 7. Then we have what we call the noble gases, or what we call the the layer gases, or the group 0 elements are what we call in group 8. So there are 8 groups on the periodic table. So these are the groups the way I was numbering according to the columns. Then these are transition element, and you study more about this later. So you just have to not say it's a transition element that are found here. Is that okay?
Yes.
Sure, that is it about the periodic table. Then there is what you call laws. So laws are the periods. So if you find this is the period 1 we have there. This is the period 2. This is the period 3. This is the period 4. This is the period 5. This is the period 6. This is the period 7. This is the period 8. This is the period 9. Doesn't matter where they are located. We are looking at the laws that you have. Is that okay?
Yes.
So if we are to count the periods that we have there on the periodic table, we can say we have period 1, period 1, period 2, period 3, period 4, period 5, period 6, period 7, period 8, period 9. So I can put them like this, but for these two we don't use them. These these ones which are down there, for your case, we don't normally use them. The actinide and the lanthanide, but we don't use them. Just know that we don't use them. But it's important that you know the periods, okay? We'll be ending mostly at period 7 in our study, in our level 1s, as who are doing the pure chemistry. So we are the one who go further into this.
Okay.
As we advance in these actinide, lanthanides, okay, the down elements.
Okay.
Yes. So in short, the knowledge that I want you to understand is about the periods. So this will help us when we do the bonding. Like we'll be able to understand what these proton numbers, these numbers without points, the proton numbers, or what we call the electron numbers. We'll be using them in bonding because these are the number of electrons. So this is what I wanted. In short, you will find that these numbers with the points, these numbers with the point, I said they are what we call molar mass. Okay,
Okay.
this down number what we call molar mass, because they will be helping us to find the moles. Is that okay?
Yes. Yes. Yes.
Okay, so they will give us a number, let's say the grams of an element, then you divide by the molar mass, which is from the periodic table, then you'll be able to find its moles.
Okay.
Sure, otherwise that is it about the periodic table, because I'm sure I've been seeing people calculating the number of moles to say it's equals to the mass over molar mass, right?
Yes.
Yes, the mass you'll be given always. Sometimes you can be asked this given the number of moles, and also given this molar mass is the one you are getting from the periodic table.
Okay.
Yes, to let me give an example of something. Let's say I tell you to say calculate the moles of, given that 2 grams of water was produced, calculate the moles. So what you say, okay, number of moles is equals to mass over molar mass. Yes, the mass that I give you is 2 grams. Then the molar mass of water, you say, okay, in water there is H2O. So oxygen has 16 when you go there on the periodic table. Let me check, where is oxygen? It's here, just that you can't see. For me, I won't put it's 15. Yes, it's here. you put it's 15.99, but me I'll put 16. Right?
Yeah.
So I'll say 16 there. Okay, then for hydrogen, I can see it's 1 there, 1 point something, but I'll say 1. So that 1, there are 2 hydrogen there. As you can see, there are 2 hydrogen there. So mean that I'll multiply that 1 times 2 to get the total number of hydrogen molar mass, which is 2. Then here for this guy is 16 already. Then you add, you get 18, right?
Yes.
So you bring this as the molar mass. It's the total molar mass of what you had. Of course, the molar mass is for single element, but when you add, you bring it and you put it down there as the molar mass, because that's what you were given as a compound. So you put 18 there, and you divide, you'll be able to find the number of moles. Let's say 0.62 moles. Okay. So that's how we'll be using these numbers, these molar mass, these numbers with a point. Will be there to help us find the. Otherwise, is there any question before I proceed to the next thing? Then this group is this element coming from. You'll be able to point. When you look at it, you'll be able to look at it. Let's say aluminum is coming from group 3 because it's there. You'll be having a periodic table when you're answering chemistry questions. So you have this. You have it, right?
Yes.
Yes. So is there any question before I proceed?
No, no.
All right. Okay, to know if this is okay with you, the whiteboard, the blackboard.
Try to write something there.
Okay, we proceed. So, okay, what you must understand is the first what we call the empirical formula. So I will explain what is this. So the first thing that we need to understand is what we call the empirical formula. How is the blackboard?
It's just okay.
So sometimes it's presented as EF. Okay. Empirical formula, you have been seeing molecules, but you haven't just been paying attention. The empirical formula is the simplest whole number ratio atoms has. For example, if I write, let's say H2O, you have seen oxygen doesn't have any number there. It means that it's possible that it had its molecular formula whereby, let's say it came from, let's say here we had 4, then oxygen we had 2. You have seen this is
Yes.
this was its molecular formula. Is the formula of the original compound. It's possible that they divided here 2 into there, that's 1, right? 2 into there, that's 2. So it's possible that it came to this point. Okay, so this is what you call the empirical formula, like the simplest. Okay, it's the simplest whole number ratio of atoms. So they are in a simple form, like expressed as ratios. So it's possible that it came from a molecular formula of, let's say, H4, then 2 there, whereby we divided these 2 there into 1. There 2 into 4, that is H2. Have you seen the logic here? In short, empirical formula is more like a formula whereby the molecule was bulk. It had a lot of number, but they were cancelled or divided by the simplest number in them.
Okay.
Yes, that is what we call the empirical formula. Alright, is that okay?
That's okay.
Alright, again, I give an example. Let's say H2O. You can see oxygen is in its simplest form. There's no number there. And also, carbon is in its simplest form. You have seen? There's nothing there.
Yes.
So it's possible that this guy came from the molecular formula of, let's say, CH12O6, which is glucose. It means that it was divided throughout by 6. You have seen? Divide 3, 6, there 6. there are 6. So they came to have H2O. This is now the empirical formula. This was the molecular formula when it had those numbers. Have you seen the difference?
Yes.
So the empirical formula, it is the form a simplest number ratio of atoms, or simplest number of atoms in that compound, like they are in a simplest form ratio, in short. So for empirical formula, it is always the atoms are in their simplest ratio.
Okay.
Gotten?
Okay, no worries. I just yeah.
Is that clear?
Yes, it's clear.
Alright, let's go to something now what we call again. Let me just, of course, I've given some points about the molecular formula, but I have to talk about it as well. And I'll give the example just to cement what I've said. So it's what we call the molecular
Okay.
formula. So you see how we'll be even finding this. So molecular formula, I'll say MF. Alright, so this is the actual number of atoms in a molecule. That's what I can say. For example, I can give the glucose formula, which is 12 there, then oxygen 6 there. Have you seen? The way the compound
Yeah.
represents, it's possible that you can reduce, you can simplify these numbers, but don't do that when it is a molecular formula. Unless when it is empirical formula, you can take it to imply
So it's carbon dioxide. I'll be very fast. I just want to say, and we'll be able to control. I'll write the answers because it's not part of the class. So for this one is sulfur, then there's dioxide there. So it's you write sulfur dioxide. You know sulfur you have on your periodic table. So just write sulfur di then oxide. Here it's carbon disulfide. Here it's sulfur dioxide because of oxygen. Here it's sulfur. This is sulfur. So it will be sulfide. Then here, coming to question 3 now, this is methane. It's a well-known thing under organic chemistry. It's a methane. There's no other way of naming it. It's a methane. Then this one, I don't know the P. The P should be for phosphorus. Okay, if it is phosphorus, it will be phosphorus trichloride because of the chlorine there are 3, but if it was 2 it will be chloride, just like that. Like the way we name, let's say, yes, sodium chloride, sodium chloride, or magnesium chloride. You have seen, whenever there's chlorine, you just put chloride until at 2. But now that it's at 3, we'll say trichloride. It won't make sense for us to say dichloride. Or it won't make sense for us to say you said it's what? Phosphorus. Okay, it's phosphorus. Okay, so phosphorus trichloride in short. Trichloride, phosphorus trichloride. Okay, that would be the name. So the first one is carbon disulfide. The second one is sulfur dioxide. The third one is methane. The fourth one is phosphorus trichloride. Alright. Is that okay? Okay. So now let me check the question. It a bit, but it's still coming.
Okay.
Okay, before I give you the question, let me create my own questions. We help each other to solve this one. Hi.
Okay.
Yes. Okay, so the first question that I have is, suppose given in percent, sometimes they'll give you in mass, sometimes in percentage, but you need to divide whatever they'll give you by their, by what you call their molecular mass. I mean the molecular mass that we looked at on the previous page. So given that, let's say sulfur, I don't know the element, but I'll say Sr, okay, is 55% in the compound that was analyzed, of which the compound you don't know. Then we have also another compound, let's say chlorine. We want to calculate its molecular empirical formula. So chlorine is given as 44.8%. Sometimes they can give you just the percent of this and they don't give you this. You need to know that the percent is out of 100. So you need to subtract from 100 to find the percent of the other compound. Sometimes compounds or three compounds, let's say A is equals to 20%, B is equals to, let's say 30%, okay, and C they don't give you anything. So you need to subtract, to add this and subtract from 100 for you to get 50. Is that okay?
Yes.
Okay, so they can trick you in that. I just have to say it. So whatever they give you, sometimes they can give you this as in masses. Let's say they give you sulfur to say 20 grams, then chlorine again they give you, let's say 13.5 grams. For these ones you don't need to subtract, they will give you the way they are, and you need to divide by their molar mass to find the moles. The goal is what they give you, you divide by their molar mass. Is that okay?
Yes.
So let's go now. So we'll divide molar mass. Is that okay?
Mm-hmm.
Okay. So let's say the atomic mass of this guy, I'm checking on a periodic table, is SR. Cyanide, something like that. It's I don't know, you can also verify with me there. SR. Just look the element with the SR symbol.
SR.
Yes.
It should be boron. What is it? Boron?
No, boron is B. B.
B. It is what?
Just check the element with
F.
SR. SR. This first element.
SR.
Yes. S capital letter then R. Check
Okay.
check in transition metals especially.
Just a minute. Just a minute.
Check in group 2. Group 2.
Group 2.
Yes, check group
Okay.
2. Check, come down group 2, you'll be able to see, I'm sure.
SR. I can only see SR, but the name is not written.
Yes, I just want the number, the molar mass.
Oh, it's 87.6.
Okay, yes. So you divide now. This is what you do. Whatever you'll be given. Suppose you're given another element. You divide by their molar mass. So for this one, I'll say 5.2 as a percent, the way it was given. Then divide by what you said, which is 87.6. Okay. Then you also come to this guy, which is 44 for chlorine. Tell me the chlorine also, the number there. It's in group 7. Group 7.
7 is 15.45. 35.45.
Okay, we normally the light 35 just 0.5.
Oh, yeah.
So I've started with these decimal places with it. You always maintain that list.
Mm.
Okay, after dividing that, here it's when I punch on my calculator, it's giving me 0.6. I don't know on your calculator, 0.63. Then then for chlorine is giving you 1.2. Divide also here. Try to divide for me here for chlorine. 44.8 divided by 33, 35.
44.8.
8. Yes,
Divided by
divide by
35.
0.5.
35.
1 point what?
1.2619.
26. This is enough because I've maintained the 2 decimal places there. Is that okay? And
Alright.
also, they have to maintain. Then from here, okay, what you do is you divide throughout by the smallest number that you have there. That's the, after finding the number of, these are the moles you're finding, by the way. I don't want just to write as moles there. Okay?
Okay.
Yes, because you are dividing by their molar masses. So, you divide throughout by the smallest number. What is the smallest number between the two?
0.163.
0.63. Also there 0.63. Here, let's go. Here dividing through by 0.63, it will give us 1, right? Then here, what about there?
That is 1 point what?
1 point,
260?
yes, 1.26 divided by 0.63.
Equal to 2.
Perfect, it has come perfect, but there are cases where you need to round off, and I'll give you what to do. So I've seen this means that cyanide, I don't know this element, it's contributing 1, of which I can't show. Then the chlorine is contributing 2. So this is the molecular formula, the empirical formula, I mean.
Okay.
That's how you find the empirical formula. So now,
Alright.
let us now try to do the empirical formula and the molecular formula. Okay? So sometimes they can give you to say, given that the actual mass of this compound is, let's say, 188 grams. Is that okay? Find the molecular formula. So what you do is, you say, okay, there is that n that we need to find, which is the actual mass which they have told you, over the mass of that empirical you have found. So the empirical you have found there, we need to find the mass, the molar mass of that compound, which is Sr chlorine 2. So this means that the actual mass which they have said is 188, then over, you calculate now the molar mass of cyanide. I don't know if cyanide, chlorine, whatever. So the chlorine, it has 35.5 from that periodic table number. This is the molar mass. Then you multiply times 2 because there were 2 chlorines. Is that okay?
Oh yeah, 2 times 10.
Yeah, which is 70. Then,
Oh.
I don't know if 71, I don't know, but you punch for me. 35.5 times 2, you can punch. Then here for cyanide, I don't know if this is cyanide or what. It has, we calculated it as 87.6. So you say 87.6. It's only 1, so it's multiplied times 1. So we punch now and add the 2. You say 35 times 2, 35.5 times 2, you get a mass there. And also
71.
71, yes. Then what is the, this is just still the same, 86.7. So it's 86, I mean 87.6, right? Yeah, you add 71 is the mass that you put there, down there. Okay? I'm just suggesting, let's say it's 36. So you divide this by 36, you get, let's say the n is, let's say 3. You have seen? So this means that you multiply throughout by n to get the molecular mass, which is the n is 3, so that will be Sr3. Then the chlorine there will be 6. So this means that this is the molecular formula. You have seen?
Yes.
Yeah, it is not in
Okay.
the simplest
Okay.
form. Yeah, that's what I've talked this because sometimes they can bring in such angles.
Yeah.
Yes, let me look at the, you see, what is there. Okay, we solve this question, eh? Aye.
Uh,
So like I'm going to delete some of the things. Like some of the things like you have seen. Like you find the number of moles of all the elements. These are just steps. Divide the smallest number of throughout of which we did. Press the nearest whole
uh,
number to the subscript. It is present an element of which we did. So I'm going to grab this and remain with the question.
okay.
Alright, are you there?
I'm here, ready?
Are you able to see?
Yes.
Okay, it says a pure compound is analyzed and found to have the following percentages. So 1 for cyanide for SR, alright? And we have also for chlorine there. We have also, oh, there are two questions here. This is nice. There are two questions. That's very, I think the first one is the one I was doing.
Yeah.
So I can do it, right? But I can explain something.
Oh yeah.
Let me do this. Alright. So yes, this is what we had. So meaning that to find the empirical formula, to find the empirical of that element, so you say the empirical formula of that element will be given as, you first bring those percentages, okay? Sometimes they can give you in masses. So you divide throughout by the molar masses, of which we said the molar masses, right?
Mm.
From there you find the moles. After you find those moles, divide by throughout by the smallest, okay? Throughout by the smallest
Yes.
number. Then what you have is the molecular formula. I mean, it's the empirical formula of that thing. That's what we did. Those are the steps we went through.
Mm.
Yes, there will be a case where we need to divide some numbers, and I'll demonstrate, but it's quite complicated, but I'll be able to if at all I meet in this question. So let's look at this question now. So we have a, a caffeine, okay? A caffeine is a stimulant drugs. Yes, like a caffeine, it can be alcohol. That's why there's caffeine in alcohol. They are what we call stimulant drugs. Stimulant drugs are the drugs that speed up the rate at which the impulses travel the body. That's just the case of biology I'm talking about. Like for example, someone scares you, like you'll be able to respond fast because of the the impulses are traveling very fast in your body to respond to danger. They are stimulating the what you call the what's this, the fright or fight hormone, which is also called as I've forgotten the name of the hormone. See,
Okay.
yes, that's the case of biology. So in short, nothing we want, like let us just look what they have mentioned. The way they have mentioned, like they have mentioned carbon, they have mentioned also hydrogen, they have also mentioned nitrogen, and they have mentioned oxygen. You have seen? This is
Mm.
what we need. So the first thing for carbon, they have given us 49. I think I need to separate. Anyway, let me try. They have given us 49.98. Then for hydrogen, they have given us, these are the numbers I'm getting. Hope you are able to see where they are coming from.
Yes.
So this guy for hydrogen, we have given for 5.15. Alright, percent. I won't write percent because it doesn't matter at this point. What matters is the data. Then for nitrogen, I
Okay.
have 28.87. For oxygen, I have 16.449.
00
Yes, for oxygen. So it doesn't matter, they can bring in percentage or whatever they bring, but just know that you divide throughout by molar mass. I mean the mass from the periodic tables. Is that okay?
Yeah.
So this means that adding throughout by the the mass on the periodic table. If you can look there on your periodic table, check for carbon. For carbon,
Carbon is 12.01.
tell me again.
12.01.
Okay, so 12.01. Next, hydrogen.
Hydrogen is 1.008.
Okay, 1.
1.008.
Okay, 001 because I'm entering two decimal numbers. Okay,
Okay.
then for nitrogen.
Nitrogen is 14.001.
Okay, then for oxygen,
6.0.
16.00. Fast, let us be fast. Now we divide throughout. Now we find, now we're finding the number of moles. Divide throughout now. This number what we have here on top, we have 48.98 divided by 12.01. Fast.
5.15. I start dividing.
Yes, fast.
5.15.
5.
0.15 divided by
Eh.
1.0.
Wait. Give me for carbon is 49.98 divided by 12.01. What is the answer?
Oh, okay. Yeah. On carbon, this is 49.
49.98. Yes, as you can see there.
9, 8 divided by 12.01. It's 4.13.
4.13. Okay,
05.
it's okay. It's okay. Then we are maintaining two decimal places. Then 5.15 divided by 1.01. Are you there?
Yes,
5 divided by 1.01.
it's 5.099.
The 5 point what?
09.
That's all. There's no number after 9.
Is another 9.
That 9 will go to that 9 and it will be 0. And that 9 which will be 0, it will be just 1 0 there. Aye?
Alright.
Yes, because it's more like we have 9, 9. And we have 0. So meaning that this one will go there, will give it will be 10. That will be 0. Then the one will come there. Have you seen? Yeah, I'm trying to maintain the two decimal process because that's what I'm trying to maintain. So let's go to the next one.
28.87.
Sorry?
Uh,
28.87.
2.06.
2.06. That's all?
Uh,
Okay. Let's go to the last one.
that's 16 point what? 49.
16.9.
29. 1 1.03.
Okay, so 1.03. So which number is smallest? Now you divide throughout by the smallest. Which number, after finding the number of most, divide by the smallest? What is the number which is smallest here?
The last one.
So you divide throughout by 1.03. So they are 1.03. So 1.03. Then they are also 1.03. Let's go. What is the first one?
Yeah.
Of course, here it's 1, right?
Uh,
Let's go for carbon.
three, one, 1.03. Is equal to 4.00.
Okay, let's go for 5.10 divided by, you know what we are dividing.
Mm. 4 point.
4 point, so you are saying 4.95, right?
Mm.
So I want to tell you, under this topic we start from 8. Like if there is 4.80, you can round off. Have you seen?
Mm.
You can round off. We want a smallest, a whole number here. We don't want a number with a decimal point. So if you find, let's say, 4.5, you can multiply this times 2 throughout of those numbers you had. Is that okay? In short,
Sorry.
you how like at this under this topic, we only start at 8 to round off, but other normal rounding off we start from 5.
Uh,
Under this topic, scenarios where you can multiply the number that you can multiply is what we call a multiple. Like in order to get rid of this 5, you multiply times 2. That will give you 1 point something, which is 5.0. You have seen? I mean, it will be like this. In short, what I'm trying to say is, under this topic, I just want to demonstrate to say there's a way we round off. When we start at 8 going up, let's say 8, 9, you can round off. But if you are below that, you don't round off. Okay?
okay.
So give me, it was 4.99,
5.
4 point what?
9.5.
So meaning that 9 it can give to give 5. Is that okay?
Sorry.
Yeah, to the nitrogen.
That is 2.006.
Give me 2 point what?
This is 1.003. This is 1.58.
Wait, 2.06 divided by 1.03. What's the answer?
Oh, sorry, sorry. Just a minute. I forgot to put the 0 there.
2.06 divided by 1.03.
It's 2.
Okay.
It's 2.
2 like that. So they have come out
Uh,
perfect. They have come out, the lecturers will tell you to divide throughout by the number you see on the periodic table. But me, I kept on maintaining these 2 decimal places, and it has come out perfect without any confusion. So you can also try to be maintaining these decimal places and round off if possible, and leave to the decimal places like that a list number has, like the way it is. Let's say if it had, let's say, 16.1 in percent, let's say, for oxygen there, you keep on maintaining that what number with 1 decimal point. Is that okay? That's what I was maintaining here,
yeah, yeah.
and it has given me the perfect
Okay.
number. Sometimes it can ruin your life. You need to multiply them. You find decimals. That's why I was
Oh
afraid.
yeah.
I was afraid. I thought I would find smos, but with the maintaining of numbers, it has come out perfect. Yeah. So this means empirical formula: carbon it contribute 4, the nitrogen the way they were listed it contribute 5, then nitrogen it contribute 2, then oxygen 1, just like that. You leave it like that. Is that okay?
Yeah.
So
Fine.
yes, so molecular formula. So here the question is, uh where is the question? Have you seen? The question is here. We have this one we have calculated, I demonstrated. Then this is what we by mass, and has a molar mass. They have given this is the molar mass I was looking for now. This is the what you call the actual mass I was saying. In that formula to find where I said, where I remember when I said to find n, you say the actual over the empirical mass, empirical formula mass. You remember?
Um,
To find the
okay.
n, give you in this case the actual that they have given is this one, which is the molar mass. So now we use that thing we have found here to find this what we need to put here.
Okay. Where are you pointing? Where are you pointing? Oh, okay. Okay. Alright.
Okay, so this is in an experiment, eh?
Mm,
So, see, the question is determine its molecular mass. In fact, we have just determined the empirical. We haven't even answered the question because the question is saying determine its. This is the empirical mass we have said, we have found, the empirical formula. So now they're asking us
okay.
to find the molecular formula. But one thing we need to understand is this is what we have gotten. And we said there is that n that govern to say molecular formula, okay, is equal to
Mm,
the empirical formula times a certain number called n, a factor called n. And how do you find this n? We say n
mm,
is equal to the molar mass. Okay, I can say molar mass. Most of it they call it molar mass. Okay, then over the
mm,
mass of that what you have found under empirical formula. Okay, so say E
okay.
F mass, empirical formula mass. So this means that what they have given us is 194.2. So this is 194.2. Is that okay?
Mm,
I don't want to like that. I just write as a number because I know n is a factor, doesn't have units. So you divide throughout by the mass of what you have found. So the mass of what I have found here, allow me to write like this on top there. I'll be writing like this. Is that okay?
okay.
Because I don't have a space down.
Okay.
So there for carbon we have 4 times what is on the periodic table? It is 12 point what?
Where's the periodic table? Oh, 4.01.
Okay, so we have 4 carbons and times 12.01. Then there we have 5 oxygens, I mean 5 hydrogen times what is the mass of hydrogen?
What was that? 5? Eh? It should be, that is
Hydrogen.
1.0. Yeah?
Hydrogen, what is the mass?
Hydrogen
Yes.
1.008.
Okay, let me do this. Let me do this, I.
Mm,
What I'm going to do is this. I want I want to get this in it will be quite difficult for us to find that value. So what I'm going to do is I'll get, you should be doing this. You get just those numbers in front there, okay? Like those numbers you have, like for carbon is 12, you give me 12. For hydrogen is 1, you give me 1. Is that okay?
okay.
Yes, the normal periodic table at secondary, thus it couldn't include these point numbers after point numbers. So I'll be using this so that I target the perfect number, because they also appears as numbers, so I want to maintain that.
Okay. 14.
For nitrogen we have 2 times what is the nitrogen? Is 14, right?
14.
Good. What is
Mm.
for oxygen? We have 1 oxygen times what is the 16. So
1 6.
it's 6. Okay, so now we can do this. 4 times 12 plus 5 times 1, which is just 5. In short, 4 times 12, it's what?
Hmm?
4 times 12
5 times 12. That is 48.
plus this 5 that we have there. 48 plus this 5.
Um,
Add, just add.
48 plus 5, 53.
There's this 2 times 14 under nitrogen, which is 28. So plus again 28.
One.
Then there's this plus 1 times 16, which is just 16. What are you getting?
97.
97. So meaning that 97 is our empirical mass. So we'll put 97 there. So divide now. 194.2 divided by 97.
194. Huh?
This one here.
Where?
We are using this small number. Remember, we are finding the value of n. So you are using this number.
Where is the RAM?
This number here on top.
Where is it? Let me check.
The
Oh,
mol
194.2.
Yes, this is the molar mass we are using. So this is what we are doing here. You need to be fast with the calculator.
It's 2.
Yeah, just punch fast the way you see numbers, then forget. Don't even say why has it come like this.
It's 2.
Okay. So this is our N2.
Yes.
So meaning that we can find now the molecular mass by saying, okay, molecular mass is given as empirical times N. Empirical we have is C4, okay, H5, then N2, then O. So we are multiplying times this N, and our N is now 2.
2.
So multiplying throughout, that will give us C
8.
8, H
10.
10, N 4,
4.
oxygen 2. So this is
2.
that is the molecular formula of that compound, and the only thing that I need to tell you is about how to multiply the multiples, like when the decimal. So like during that stage of dividing, that's where now this will come in. Okay, after dividing by the smallest number, under that stage, challenges such as, let's say, when you have, let's say, 0.5, okay, you have remained with 0.5, multiply that times 2 so that you can balance that one. Okay,
Okay.
then let's say you encounter such problem. Let's say you have 0.33, this one multiply times 3 so that you get to have 99, like the way we did for that number. Like I think we divided by, we rounded off 9. I said we start from 8.
Okay.
Then let's say again you have 0.25, this one you multiply times 4. Why? 25 times 4, it will give you something like 5. I don't know if it's 20 or what, 50. So of which you, in short, you encounter this problem, but I don't want to disclose how be multiplying. Okay, try to multiply 25 times 4. What will be the answer? Is 100, right? So means that the one who come there will drop there. Then here times 3 to give you 9999. That 9 now it can add there to 0, then to get 1 there. You have seen? Then the 2 there it will multiply times 10 to get 1 there. This is the whole reason why we are bringing all these 2, 3 factors. Problems the way we have 0 0.5, 0 0.33, 0 0.25. That's why I've made sure that I need to tell you.
Okay, okay.
So in summary we said the empirical formula. First, you'll be given whether in mass, or in percentage. Divide by their molar masses from the periodic table. From there, now divide throughout by the simplest number there among themselves. From there, then, if you encounter these problems of 0 0.7, 0 0.7, multiply with what I've just said throughout. Okay, you multiply. If you meet like you are multiplying times 2, multiply times 2 throughout again. Whatever you do should be affecting everything. Okay, so that is it. Otherwise, I think to the molecular formula and the stuff like that. So this I'll send the homework and drop it to 097 in case there are people who watch this video. 20920 there. Okay, they should inbox on WhatsApp. In case there are people who watch that video.